Alright, so let's see if I can get this last video knocked out. The last one that I want to mention is electronegativity. This is our last trend. I usually use the abbreviation ENEG in my classes. It's just a lot shorter than that big old long word. Let's see here. So, electronegativity, by definition, is the ability of an atom to attract an electron within a bond. So, who wants electrons more? Who is more interested in getting these electrons? Hey, you got to listen to the annoying bell anyway. There we go. So, the trend is, as one would expect, about the same. As we move across a period, our electronegativity increases. Why? Guess what? Bigger magnets. Same reason as always. So my nucleus is better able to attract the electrons than an atom with less protons, smaller magnet. Also, as we move across the periodic table, just like ionization energy, we're moving closer to that full octet. Electronegativity is effectively the opposite of ionization energy. Ionization energy, we're yanking the electron off. Electronegativity, we are attracting electrons. As we go down a group, each row adds a new ring, which makes the electrons further away from the nucleus's power. That shielding effect, as we put more rings between the nucleus and those outermost electrons, the nucleus's hold on those outermost electrons gets weaker and weaker and weaker. This is actually a measurable number. If you know anything about polarity in bonds, this is what determines polarity. How well can an atom attract the electrons within a bond? How much does he want them? You can look at the electron configuration as well, because the closer we are to a full octet, the more the atom is going to pull on those electrons and try to make them their own. On the periodic table, two elements of particular note. Francium in the bottom left corner. Francium has the lowest electronegativity of any other atom on the entire table. Reason for that? He has a fair number of protons, 87, but he has 7 rings and only 1 electron on that outermost ring. So he doesn't really want that electron anyway. The atom is not able to hold on to that outermost electron very tightly. 7 rings away is a long way, and only 1 electron means that he's going to have to lose that electron in order to make a full octet. Second atom of interest is fluorine. Fluorine has the highest electronegativity of anybody else on the periodic table. Reason for that, he only has 2 rings, he has 7 valence electrons, and only needs 1 more to complete that full octet. His electronegativity, I think, is 3.98. It's the largest number you'll find out of any of the other atoms on the table. So that's just a quick summary of electronegativity. Hope that helps. Thanks, bye.